Tanmay Vishwash, I welcome you all in my channel Chemistry, the Mystery of Molecules. Today we are going to discuss a problem presented in front of you. This moiety react with one equivalent of peroxyacetic acid, and what is the product? Four options are provided in front of you, so you have to answer what is the right one. Okay, so now let's start. So before going to details, we should learn about the nature of the reagent. Okay, so two things is given as a reagent, this molecule and paracid. First let's discuss this molecule. This molecule is actually a ketone because this keto group is there. This is the double bond, but it is conjugated in ketone, alpha beta unsaturated carbonyl, and rather to say because this is an electron deficient carbon-carbon double bond compared to this carbon-carbon double bond, because it is not in conjugation with any electron deficient or withdrawing group. Okay, so this is the difference between two double bond. Now another reagent is peroxyacetic acid, or better to say paracid, and this will react. The interesting point, you should remember that this paracid, this oxygen have -1 oxidation state, which is unstable. That's why they prefer to undergo reactions such that they can oxidize someone and they can be itself reduced to -2 oxidation state. Okay, so this is the basic thing. So in this case, which position they'll oxidize? Actually they will oxidize alkene. And another thing, since it is an electron deficient oxygen-oxygen double bond, oxygen-oxygen bond means it's a peroxyl linkage electron deficient, so they will attack electron rich double bond. So in this case, which one is electron rich? This one. Okay, so reaction will happen this double bond and this. We will discuss. Now another question is, who is more reactive? Means remember, who is more reactive and more selective? Trifluoro, this paracid, or this acetic acid, paracetic acid, better to say peroxyacetic acid. So if you look at this lone pair, there is another phenomena, lone pair repulsion. There is one lone pair, there is one lone pair. So these two lone pair repel each other. That's why these molecules are unstable. Now if you put any electron withdrawing group attached to this lone pair got delocalized and stabilized. Now so withdrawing nature of this group helps to stabilize this molecule. In this case, if you look at difference is CF3, means CH3 and CF3. So if CF3 is there, it helps to withdraw more, so it gives the reagent more stabilization, and when the reagent is more stable, it is less reactive, more selective. This is the simple. So another thing, reason why CC reacts with paracid, because this carbon-carbon double bond electron rich and this peroxide electron deficient, that's why they react together. And another thing, why peroxyacid compounds are more reactive than water or oxygen? See, in water the oxidation state of oxygen is -2, in molecular oxidation state is 0, but in case of peroxy compound oxidation state is -1. This is an intermediate oxidation state. That's why peroxy compounds are reactive and prefer to go -2. And another thing, as I told, this lone pair repulsion, which is known as alpha effect. Okay, now so if we look at the reaction mechanism, look at very closely, this is the organic molecule. As I told that this double bond will undergo epoxidation, so this undergoes epoxidation. By the way, I've already discussed in a previous lecture about the mechanism, so I'm not going to explain here. Please visit that lecture. So in this case, I want to tell you that what is the transition state. Transition state is this one, student. Try to remember, it is helpful. And another important information, now a clue, I can say that which oxygen is converted into this epoxide, which is the epoxy oxygen, this one or this one. So answer is that this oxygen is transferred to this alkene, means this one. How I am saying this? Just look at the transition state. See, this oxygen is actually getting attached to this alkene, and which one? This is actually this one. Okay, so this one is this one. So this is the important thing, you know. And if you look at this molecule closely, see, this is a -2 oxidation state, so it means that oxygen have reached its stable oxidation state. And not only that, the other part of the other oxygen, means this attached to carboxyl group, it also have -2 oxidation. Sorry, this is -2, this is -2, both are -2, that means both are stable. Now what is the answer of our problem? The answer is this one. Okay, so now question is that if two equivalent, okay, I'll give this Q1 to you. It's a very easy, you have to understand. Okay, you have to write in the comment box what would be the product if two equivalent of per acid use. Now the second question is, what is the expected product if sodium hydroxide and hydrogen peroxide use? So remember, this sodium hydroxide and hydrogen peroxide produces hydroperoxide anion, which act as a nucleophile and is responsible for epoxidation, and actually this does the epoxidation on the alpha beta unsaturated carbonyl. I have already uploaded a dedicated lecture, please visit for your better understanding. Okay, so now in conclusion, what you have learned, that peroxy acids are electron deficient compound and nucleophilic attack on them is possible by electron rich double bond, which can act as a better nucleophile. For electron deficient alkene, we can choose hydrogen peroxide sodium hydroxide combination, and Baeyer-Villiger oxidation another possibility which converts ketone into corresponding ester. But in this, if you use cyclic ketone, that is the lactone. Now another most important thing, please remember, oxygen is most stable at its -2 oxidation state because it's electronegative, so it prefers to keep electron on itself. So -2 oxidation state is most stable, and that's why we see the stable molecule of oxygen is water. Okay, so this is the end of this discussion. I thank you all for watching. Please like, comment, share and subscribe my channel if possible. Please